morning, everyone. Today marks the final day of our Innovation Week, a journey that has truly been inspiring and enlightening. Over the past 4 days, we explored diverse dimensions of innovation and architecture, from understanding the roadmap to entrepreneurship to delving into the intricacies of innovation in design. Every session offered a unique perspective on how creativity and technology are shaping our field. As we conclude this remarkable week, we are thrilled to host Ar.Krishna Murthy, an exceptional visionary and innovator in the architectural realm. Ar.Krishna Murthy is a principal architect at Folds Design Studio, a pioneering architectural and production house based in Navi Mumbai. Now, this is something which we all are going to be proud of. He is alumni of Bharati Vidyapit, first batch, Mumbai. So he completed his BArch from Bharati Vidyapit College of Architecture, CBD, Navi Mumbai. With a passion for futuristic and technologically advanced designs, his expertise lies in exploring diverse materials and transforming complex projects into feasible realities. Under his leadership, Folds Design Studio has evolved into a powerhouse of innovation, operating a massive 60,000 square feet of design and fabrication house with a team of over 300 architects, designers, and artisans. The studio specializes in intertwining digital design, AI, and sustainability to redefine architectural practices. Through years of research and practice, they have bridged the gap between design, technology, and the built environment, creating iconic spaces and bespoke designs. Today's seminar, titled Innovation, Development, and Technology Readiness in Architecture, will provide key insights into advancing innovation in architecture, technology readiness for design solutions, and future-driven architectural practices. So please join me in welcoming Architect Krishna Murthy as he takes us through his inspiring journey and groundbreaking work. So now I request our principal, Dr. Kavita Murthy ma'am, to please felicitate our guest. Sir, the stage is yours. Right.
Okay. Good morning, sir.
Good morning, sir.
It's a big week, right? Too much amount of innovation, too much amount of design that you guys might have learned, too much amount of topics that were shared to you guys as students for the past 5 days. You guys can hear me?
Yes.
I can't hear you.
Yes, sir.
I still can't hear you.
Yes, sir.
Still can't hear you.
Yes, sir.
No way, this is not how Bharati Vidyapit is going to respond to me. Come on.
Yes, sir.
This is how you treated NASA?
No, sir.
Come on. All together.
Yes, sir.
That's good. थोड़ा एनर्जी लाओ यार. 5 दिन निकल गए इसका मतलब थक गए. This is not correct. And unfortunate मेरे लिए है कि all the time in Bharati Vidyapit, Mumbai also. I think last year I gave a lecture and it was a whole day session. And they called me at the end. और आधा घंटा दे रहे बोलते कि टाइम खत्म हो गया, सर थोड़ा बात करके निकल जाओ. And this is not the right way. Now again BVP put a says, थक जाओ बच्चे लोग, एंड में we have one person from BVDUCOA who comes in, who is going to speak a lot for you guys. And you guys are tired. Are you tired?
No, sir.
Ah, that's right. Again, once again?
No, sir.
We need to be alert. You're architects, right? Clients जब हमारी बजाते हैं ना, तभी हमें alert रहना पड़ता है. ये ध्यान में रखना कभी भी. Okay. So good to meet you guys. And when I got a call from BVDUCOA, I said, यार जाना तो पड़ेगा. I mean, this is where I belong to, right? Whether it is Pune or Mumbai. And I think 1994 is the day that I came to Pune for the first event that we wanted to organize. Okay, at Navi Mumbai. So I was the first general secretary of our college also. So बहुत कुछ किया है अपने लाइफ में. दमदाटी, झगड़े, हमको ये करना ही है. We want all this. So we had a lot of fun. Of course, you guys also might be having fun, but I hope today also we'll have some fun on innovation and design that we are looking at. So जितना भी tiredness था वो सब थोड़ी देर के लिए भूल जाओ. And I hope that I'm really going to make sure कि तुम लोग को बोर कर सको थोड़ा ज़्यादा और ताकि जल्दी भाग जाए. Okay. So what is Folds Design Studio all about that we practice at Mumbai? This is not a regular architectural practice as everybody does. This is a little off the track architectural practice that we started. I mean, I started it almost 17 years back. Okay, so over a period of 30 years of experience, जो आज हम 30 years का तुम लोग मना रहे हो a week. Okay, so 30 years of practice in the field of architecture. For first 10-12 years, I was working the regular architectural practice that everybody used to do. But one fine day, there was a big hit that I got from the municipal corporation, and because of which I had to change my direction. Because I didn't want to practice that kind of an architecture, and I shifted, a complete shift in the field of architecture, but yet practicing architecture. That is something which is necessary. So there might be multiple, areas where you might get depressed, multiple times that you might get depressed. Things may change, things may not work as you want to work with. But the confidence in you is necessary, one. And what you're going to learn in the field of architecture is, as an architect, we are the most responsible people in the world. Okay, because we are building things. We are building things which are going to live long. But unfortunately, while coming down today, we were listening to a TED talk, me and Abhishek. And then in that TED talk, we heard that the buildings are only living for 40 years nowadays. And after 40 years, you have to go for redevelopment. So the buildings are broken and they become dilapidated. And that's the biggest problem that's happening. And this is happening worldwide. We thought it's happening only in India. Till now, I was just thinking that this is happening in India, but it is not. Because Thomas, what's his name? Thomas Hedderwick. So we were listening to his TED talk while coming down, and we realized that buildings are getting dilapidated worldwide. Architects are practicing the same shit all the time. Not only in India, but everywhere. हमें ऐसा लग रहा था कि we are the only guys who are working like this, but it's not that. It's common everywhere. So we don't have to worry about it. 90% of the architects are practicing the same way worldwide. Only few architects are practicing a little different. So you have to understand where you want to fit into. You want to work different or you want to work in the same practice. For me, when I started my practice, I never know what I am supposed to do. Generally, we work with architects or हम सीखते हैं कुछ और करते हैं कुछ. But one fine day, because of certain kind of problems, I shifted, and that shift has driven me to that extent that we have gone beyond certain things. So every day today we are taking up challenges to do things. Practicing architecture. Very important is practicing architecture. That is something which you need to keep in your mind. You should not lose that intent that you are not an architect and you are something else. Okay, but practice architecture in a much better way because architecture is everywhere. So what I work with is we have a factory setup which was necessary. Why? Because as architects we just don't design, we also build. हम जो भी काम करते हैं हम चाहते हैं कि we need to build that, we need to construct that. And construction is the major part in our industry. If you don't construct, your design is just an art, right? Your design has to be constructed, it has to be used, it has to be functional, very important. So until unless your design doesn't get constructed or design doesn't get executed, it will just be an art. While I was designing my projects, where I was facing problems, where my contractors couldn't build what designs that I am looking at, right? My laborers could not understand what I wanted to, what I was designing, and the information that I was trying to send them through these working drawings that we do, right? I couldn't convey my message in a right way so that I can get my projects done. So this happened after that first 12 years of my practice when I started my own. In that 12 years, after those 12 years when I just started, I realized that there's a big problem, there's a big gap between an architect, his information, and his information passing on to his laborers or the contractors or the subcontractors. There's a big problem. So there's a big gap. How do you, come closer, right? How do you make these people understand that what you want? That's where I started understanding that we need machines, we need technology, we need people, we need to teach people also, we need skilled people. So you need to spend a lot of time. So past 17 years, it is still a struggle, but the struggle is little lesser, but it was a huge struggle to build up people, to teach people, to make them understand what is important and what is not, how to understand these drawings, how to build these drawings using technology. Because technology is something which was missing in the field of architecture for quite some time, and it is still missing. In the field of architecture, technology is something we always talk, but we don't practice. That's the biggest problem. But in automobile industry, we talk, but we practice technology. Medical, we talk, we practice technology. Aeronautics, again we talk, but we practice technology. Very important. But architecture is the only field where we don't. And that's the biggest problem. We all need to understand that in other fields, especially if you are talking about a practice of a CA, practice of a lawyer, practice of a doctor, anywhere in the world, if a lawyer has to practice, he has to go and fight his own case. Then he wins. A doctor has to operate. तब जाके वो आपका उसका operation clear हो सकता है. But in our field, we design, but our things are built by people who don't know what design is, right? Who don't know what the details are, who don't know what we want. So it's the information that which is passed from one person to the other, and there is a loss of information. And who is going to bear for this loss of information? The designer, the architect. So all these things we wanted to reduce, and we wanted all these things to be erased from our practice. We want whatever information that is sent from us should go directly to the people who are working with. Hence we started out with a factory setup. We said we'll have a factory setup, but a factory setup with machines. And what are these machines? These machines which will help us out in terms of building the designs that we do, right? So we dream a lot. ऐसा करना वैसा करना. Multiple times your teachers might have said कि अब ये project बन नहीं सकता है. Correct? Change. हुआ रहेगा ना? कि नहीं हुआ है? हुआ है?
Yes.
कितने लोगों के साथ? बस. So multiple times these things might have occurred. You have a redo. Don't do this. This is not possible. That's not possible. This is not possible. These things might have happened. We also went through that process. But in last 17 years, from where to where we are today, we have erased the thought process that this can't be built. Okay, everything can be built, whether it is an installation that you want to do, or whether you want to make a building which has got a multifaceted facade, whatever it is, whether it is sustainability, whether it is MEP thing that we are trying to incorporate into our design, everything is possible. So what we have incorporated into our factory setup is the machines that we are looking at. Okay, so this is the first machine that I got in 2007. Okay, so that's almost 16-17 years back that I bought this machine. Client को टोपी पहना के. Okay, so you understand client को टोपी पहनाना. Client को टोपी पहनाना मतलब client से बोलना कि बाबा पैसे दे, मेरे पास पैसे नहीं है. But if you want something really good as a project at your house that I'm trying to do, you need to help me out in giving me advances so that I can buy one machine, such machine which will really give you some exclusive project to you. So I had to convince the client. So fortunately, एक क्लाइंट का 2-3 प्रोजेक्ट करने के बाद जब तीसरा प्रोजेक्ट हम कर रहे थे, we were doing a bigger project for him, and that given period of time, because of the trust value that he had, he could finance me to buy the first machine. Okay, so this was the first water jet machine that I bought in 2007. You know what a water jet machine is? Are you guys aware of that? हाँ कर रहे हो. You know what a water jet machine is?
सबको cutting times.
हाँ. And what? So no worries. मैं बताता हूँ सर. Don't worry. I'm here to teach you guys all that. So water jet machine is like a monster. That's what I call it. Because it can cut any damn thing. It can cut stone, it can cut tiles, it can cut metal. It can cut metal up to 150 to 200 mm thick. Okay, 200 mm thick metal, whether it is MS, aluminium, your copper, brass, whatever. So, and it cuts with water. Along with water, you have to introduce garnet. Garnet is again a silicate. It's a sand particle. Garnet and water, along with that, it passes through a nozzle of 0.3 mm. Okay, and then the cutting happens at a pressure where you're using a pump of 50 HP. At that given period of time, and with that pressure, it can cut up to 200 to 250 mm metal, up to 300 to 500 mm stone it can cut. So that's the beauty of this machine. But it is a two-dimensional machine. It's a two-dimensional machine. We need to understand this language also. As architects today, if you're going to go out and practice, you should know this machineries that we are going to talk about to you guys. Okay. So this is a two-dimensional machine. Of course, nowadays a three-dimensional water jet machine has come into the architectural practices. Till now, it is being used by automobile industry, but it has come into the architecture industry as well. When I am saying two-dimension, what does it mean? Two-dimension means it cuts like this, X and Y. Right? When I say a three-dimension, it means X, Y, and Z. Exactly. So this is a simple thing that we all know, right? So this is a two-dimensional machine which cuts all these things. You can also cut concrete blocks. So any design that you want to do, whether it is an inlay job that you are trying to do here, whether you want to cut a molding that you want, or you want to cut metal to do insert, or probably wood and metal you want to insert, MDF and wood or MDF metal and stone that you want to insert, you can use this machine and cut it. We also cut glass. If you see, we also cut glass. That's a mirror that I am cutting, which is just 6 mm. So you can also cut mirrors and have different kind of shapes. You can also do mirror inlay jobs where you can insert mirror, metal, or probably mirror, metal and wood. All these things you can insert and play around with it. So you are trying to play with different kind of materials. What are we? We are architects. Every day it is the touch and the feel of materials that we work with, so that we can do a better project, right? Materials is something which we need to understand in a much bigger way. If you don't understand these materials, then you can't do anything. You can see we are trying to cut concrete blocks. We are trying to cut a plywood. Plywood is something which nobody will tell you that, using a water jet machine, you can't cut ply or you can't cut MDF. That's what people will say in the market. But these are our in-house machines. So we experiment every day with our machines to understand what are the materials that we can cut, right, using these machines. So we keep experimenting. So we realize that you can cut ply as well. So the beauty was to cut a ply. And best thing is, if you're cutting using water jet and cutting ply, it is the cheapest way. Again, economics is important because it cuts very fast. Otherwise, if you're cutting tiles or metal, it becomes too expensive. If you're cutting ply, it is very cheap. That is one thing we need to understand. By using this machine at the first time, 2007 and 8, what is that I built? I had to convince my client to build this, a swimming pool. We were building a 20,000 square feet swimming pool. It was a huge bungalow that we were designing. That's the pool where we tried to procure this machine and execute that pool. So I had to convince my client to execute this 20,000 square feet pool, where we cut tiles, Indian stones, granites, Indian stones such as slates and granites, and also some Italian details, okay, Italian marble. And the aqua blue thing is a mosaic tile that we have used. To create that design, we had to procure this machine so that we could give the client in a much cheaper way. Usually when you are using water jet machine, the outcome cost is a minimum 2,000 to 3,000 rupees a square feet when you are doing that kind of intricate designs. But by procuring this machine, I could deliver the client at 350 rupees a square feet. Now just imagine, from 2000, 2500 to coming up to 350 to 300 rupees, that was a drastic change. 2500 I could have told the client, he could have afforded it, but the area that I would have done would be maybe about 300 or 500 square feet. But in this case, we have done an inlay job for almost 20,000 square feet. That was very important. So this is a product. End of the day, it's a design, it's a pool, it's a functional pool, but end of the day, we call it as a product. Okay, if you're using machines, what all you can do. So this is what we did. Other than this, what else we did? We have cut birch ply. This is an installation that we did at T1 Bangalore Airport for a very, what do you call it? It's a lounge which was designed by another architect. But we did 2 installations in the Bangalore Airport. So this was one. So it's completely a parametric calculated design using birch ply. But the best part in this is, it's not straight. It's changing its angle at the corners. But when it is changing the angle at the corners, it still has got that 18 mm gap in between. How do you design that? That also matters. So you need to have spacers that have to be designed. So this is an architectural part, not the machine language part. But when you're designing spacers, who will cut these spacers for you? The machine will cut the spacers for you. Because machine will cut the spacers with precision. But that the same thing if you want to cut with a regular, a carpenter does it, he will misplace it by just say 1 mm, 2 mm, angles change ho jayenge. Then the whole design, the information that you are trying to send from your design to your carpenter will change and the whole design ki lag jayegi. Correct? So to avoid that, machines help you all this, to do all these things, and then your laborers will help you in terms of fixing all this. Then your job is done. So machines ka purpose kya hai? To do all this. Then what you are seeing on the right is a table that we had designed. How did we do that? By cutting the marble, 4 4.5 slabs of marble, and we did that 16 feet long table to reduce the cost again. All this is possible, and even to match the grains that we will see in later slides. Then this is a CNC machine. Next is a CNC machine. We have learned what a water jet machine is. Now this is a CNC. You guys are aware of CNC machines, right? You should be. Correct? You are in a multidisciplinary compound where there are engineering colleges, architecture colleges, the other institutes are there. They might be having these machines. You might have seen it or not. Yes or no? No? Oh my God. What batch of students are these, by the way? Huh? Everyone is first year? Then? Third year we have. Oh my God. Second, third and first. Mixed hai. Diploma bhi hai. Oh my God, that's good. Masters bhi hai. Very good. Tomorrow I'm giving a lecture to 6th, 7th, 8th and 9th standard students. Jai Hind College में जा रहा हूँ मैं, उन्होंने invite किया to give a lecture there, 6th, 7th, 8th and 9th. So no worries. There's a lot of learning that will happen for me also. So anyways, so this is a CNC machine where CNC machines are 3-dimensional machines. So it has got 3 axes, it has got 4 axes, it has got 5 axes, it has got 6 axes, it has got 7 axes also. When it goes up to 7 axes, that means you are using robotic arms. Okay, 6 axes again robotic arms. 5 axes, they are all CNC machines. So in this case, these are CNC machines. By using CNC machines, what are the materials that you can work with? You can work with materials such as metal, wood, stone, ply, glass, concrete, and any other material that is available today in the field of architecture. You can work all these materials using these machines. So whatever design you have done using your software, you can literally cut them, engrave them and get the end outputs. Okay. So by using these machines, what we are doing is, in this case if you see, that's a 4-axis machine where we are cutting concrete. We are engraving concrete. It's a 4-axis machine. When I am saying 4-axis machine, that means X, Y, Z, there is a head which is actually moving. That's the 4th axis. Okay. So that's a 4-axis machine. We have got up to 4 axis and then robotic arms. We don't have a 5th and the 6th. Okay. Then what you see is, there we are cutting concrete. Again, we are cutting lightweight concrete blocks and creating moldings for an architrave of a house. Okay, so it's an architecture that we are doing. Then we are cutting marble, we are engraving marble to do inlay job. To inlay using brass. So that's also possible. Okay. By using this machine, what have we done? We have cut ply. Okay, this is again a bench that we did for the same airport, T1 Bangalore. So this whole bench was designed and built using only 3 ply. You can see there are 3 sheets at the bottom. So using just 3 ply, we have done this 12 feet long bench. So saving material, that is also important. If you are sensible enough, you understand the technology much better, you understand the software much better, which is necessary today from day one itself, from the first year itself. If you learn all the softwares, you can get these things in board. Okay, and this has been done with only 3 slabs, 3 sheets of ply. The whole bench was done. We have cut them and stacked them one above the other. Got that as a result, stacked them, then grinded it. We could have used the machine to do the CNC job as well, to do the 3-dimensional job, which we did not. We thought because there was other work also happening. But we have grinded it out to get that kind of an outcome. What is that outcome that you are trying to see? We use ply, but what does that end outcome look like? Sorry?
Stone.
Exactly. So the finish is a stone finish. It is absolutely a stone finish. We also use composite marble. We heard about composite marble. Do we know what a composite marble is? No. You should know. See, as architects, हम क्या कर रहे हैं? We are just sitting in the college, just trying to educate ourselves, whatever the teachers are giving you. Please don't do that. You have to go into the market. From day one, first batch ho, your final batch ho. You should go into the market, enter into the market and find out what kind of materials are available in the market for you to practice with. Necessary hai. Please don't think that that's not your job. Teachers are going to teach you. Please don't do that. जाओ मार्केट में फाइंड आउट करो, गलियों में घुसो, एक एक दुकान में जाओ, चाहे तो काम भी करो वहाँ पे, बट मेक श्योर दैट यू लर्न एंड अंडरस्टैंड दिस मटेरियल्स. इन दिस केस we entered into a marble company which makes artificial composite marble, which sells composite marble, which company's name is Kalinga Marble. This is at Silvassa. We went there, we were procuring this composite marble. At that given period of time, we said we want to understand how the making is done. So we went into their making factory. So while this thing was happening, I understood that there are different kind of grades of stone powder is mixed together, and there are certain kind of resins, that is resins, then adhesives. So there are 2 types of different adhesives that they, which we call it as binders. Okay. Along with this, they mix together in a bigger chamber and then they pour it, and then the drying happens. All this takes place within hours. So you can cast one slab of 8 by 4, 4 by 10. Within, let us say, 30 to 35 minutes, you can cast the slab. That's how you can do. Now, being an architect, right? What I understood is whether I could use this raw material with a different purpose. As an architect, I thought, why can't I take this raw material from them and use it as a different purpose? So I got the raw material from them. I mixed these materials. I put that into my compressor, okay, the gun, the way the polishing guy does. Now this is something which nobody does it. What we did is, हमने उसको raw material को लाया, procure किया, छोटे गन में डाला, सिर्फ nozzle का size बड़ा कर दिया. Nozzle का जो size है, the outcome of the nozzle, that we increase so that the resin passes through it. Because the particles of, these are sand particles, right? These are stone particles. They have to pass through the nozzle. We thought that we will use that technology. We used that technology and finally we could achieve this stone finish on the product. So this is what an innovation is all about. We need to understand as architects, we are not just supposed to buy what is available in the market, we can also treat them, change the way they can be used, right? They can be used in a much better way as well. But that can only happen if your minds have that kind of a capability to think and change the way they are actually presented to us. So we got this made. Other than that, what else can we do using these machines? As an architect, I have also built sculptures like that. I have made a dining table like that, which is like a fabric using a 14-inch, one thick wooden log. We have done those columns in Bangalore airport again. That's a 14 feet height single column. Now just imagine all these kind of designs. This is a door, right? That's a center table, that's panel. All these things are architectural elements. These are the things that you can do using these CNC machines. So you should be aware of these CNC machines, much necessary. If you are not, then you can't do anything. I'll just go back to the earlier slide. In this slide, what you also see is at the bottom, right, there are some tools that you're trying to see. As architects, we need to understand these tools in a much better way. Machines तो हमें पता है, machines कुछ ना कुछ कर देंगी, right? Those tools actually create that magic. Those are the tools which create the magic to execute the designs that I'm trying to show you. And those are the tools which will tell you at what cost I will be giving you the design. Okay. People working in the industry, people having these machines will not tell you what cost they can give you. They will literally say, hour का इतना है, ये इतना cost है, 2 घंटा करोगे तो इतना होगा, ये material है तो इतना cost होगा. But if you are aware of those tools, those bits, those carbide tools of different sizes, various cutting lengths, if you understand them better, you know that at what cost you can literally guide your vendor and tell him, Baba, use this tool, ये price पे मेरा काम निकल जाएगा. And that is what is important. We need to learn all that. How you will learn, I don't know. Okay. You can come to Folds. We will teach you at times. That's not a problem. But you need to learn all this. We have learned all this. Today we are at a position where we can build our own CNC machine as well. Okay, that's very important. All these have been done using CNC machines. This is a project that we are doing. That's a panel, wall panel in marble. That's a spa that we are doing for a house. Again, completely, this is Kadapa stone. It's been engraved using Indian traditional carvings. We have engraved that. That's a staircase that has been designed for a house again in Mumbai. So it has got a laser cut metal stable structure inside. Then the wood was stacked one above the other so that we don't waste too much amount of wood. Then we use CNC machine to engrave it so that we can get that kind of a design detail. On the right corner, what you're also trying to see is a curtain kind of a thing which was engraved in wood, teak wood. So we could get that kind of a design detail as well. So all these things that you're trying to see is all done using CNC machines. So if you're aware that CNC machines are available to you in the market today, whatever you're thinking, whatever design that you're thinking, everything is possible. Nothing is impossible out here. Then this is a metal laser machine. So metal laser machines cut metal. Metals, aluminium, brass, copper, MS. But in this case, when you're cutting MS, to a certain extent, you can cut MS with air. You don't have to use oxygen or nitrogen or carbon dioxide at all. You can cut metal up to 5 or 6 mm only using air. When I'm saying air, that means again you're reducing the cost. This is something which you also need to understand. Everything is related to cost. Okay. So these machines also cut at a certain speed. This is something which people are not aware of. These machines cut at a speed of 30 kilometers per hour. Just imagine. Right? If you're saying that you want to cut 1 mm, then I think 30 kilometers per hour is something which you can do. If you're cutting 2 mm, that reduces to 20 to 25. 3 mm, again 5 to 10. 4 mm, maybe 5. Right? This is something which you should know. Why? Your vendor will always cheat you because he is there to earn money. As a designer, many times your clients may say, "Yaar, ye itna paisa main kharcha nahi kar sakta. Please change the design." And at that given period of time, if you say, "Nahi, I don't want to change the design, but I want to give you the same design, but with a better price." So you should know these machines are available with certain kind of technology and certain kind of details, so that you can give them at a better cost and your design is built, right? So using metal laser machine, what have we built? So that's a bungalow that we are doing in Alibag. So that's a parking building which we have designed. That's a bungalow which is going in Kolar, that is at Bangalore. That's an installation, that's a lobby that we have designed. At the bottom, these are installations that we have done. So using a metal laser machine, what are the kind of designs that you can execute? These are different kind of designs having different kind of details using computational programming tools. We try to create this kind of designs today, and it is, believe me, everything is possible. That bungalow, we're going to talk about that bungalow. That bungalow has been designed using just 6 mm sheet metal. The whole slab of 9,000 square feet has been designed having a thickness of only 20 mm slab. Only 20 mm slab on which minimum 20 to 30 people can stand. Okay. Now this is a CO2 laser machine. This I think you guys might be using in your college as well, because to make models, many times students use this machine. So CO2 machine is available very commonly. Okay, again this is a laser machine. It's a two-dimensional machine. But this two-dimensional machine can also do what? Not just make models, but it can also design panels like that. We have done an IT park building where we have made a almost 120-meter long model, okay, which is a part of an interior job. But what this laser machine can also do is it also can engrave glass. It can also engrave tiles. This is something which nobody will tell you. Okay, so if you want to do certain etching on your tiles, we talked about tiles. If you want to do certain etching on tiles, certain pattern, inlay pattern, or some engraving detail, you can use CO2 machine to engrave. You can also do etching on glass. You know, you have some mirror panels or you have some glass panels. You want to do some etching details, you can use glass and get your job done. So CO2 machines will help you or probably guide you doing this. Now these are the latest things. So these are 3D printers. We know what a 3D printer is, right? So it's everywhere. But how to use 3D printers? What is the technology? Whether they are really reliable to work with or not. All these things are necessary. So we also work with 3D printers. Multiple 3D printers is what we have to produce things like tables, wall panels, ceilings, anything that you want to design can also be you can build them by using 3D print technology. So in this case, I'm just trying to show you that there is a dining table that we have designed. So the whole module was designed using again conventional programming. So it was a 3D model was done. Then it was taken into your software, the 3D print software, where this whole product was divided into multiple parts. Because we have got a machine which is only 400 mm by 400 mm by 400 mm. That is the build volume that the printer can build. So I had to divide this whole project into multiple pieces. So then it was sent into 3D printing. The 3D printed material, the outcome was joined together to get that form. Okay, but it's a dining table. So just having a 3D printed material, you can't build your, or probably it can't take the load, right? Then we had to insert reinforcement into it. Okay, we inserted reinforcement into the 3D printed material and poured artificial marble into it so that it gets the strength. So that's a solid piece of a stone product at the end of the day. So we have poured composite marble into the 3D printed detail that we got and got the end product as a dining table where you can put a glass of a load of almost 300 to 400 kgs, above which you can have also 4 to 5 people sitting on top of it. Because many a times we also need to understand what is the strength your product is going to take. So that's what we did. So end of the day, you can use 3D printing and build multiple things. So these are the designs that we have built. That's a sofa that you are looking at. That's again a different kind of a sofa. These are projects that we are doing. That's a bench at the bottom. That's a house that we have designed for an architect. This is a wash basin that you are trying to see. That's a chair, right? All these designs that we are looking at right now here, which come from here, right? We think all the fluidic art that we are looking at, fluidic designs, mimicking from nature, trying to make sure that we can design them, sketch them and design them using software. But how do you build it? They can be built. That's a chandelier on top. You can build everything. So the beauty is to understand machines. If you don't understand machines, nothing. But then everything will come with a cost. If you understand what these machines are, the cost gets reduced and you know that your outcome is possible. Then comes your concrete 3D printing. So this is not our in-house technology. This is in Pune only. So we have tied up with some other agency where we could understand how concrete 3D printing can help us out in terms of doing things, building things. My interest in concrete 3D printing as a designer would be to use concrete 3D printing to build complex geometries and not simple geometries. Hence, till now, to build complex geometries, concrete 3D printing has not gone to that extent. Simple geometries are easy to build using concrete, but complex geometries, it's a little difficult till now. So these are just experiments that are happening. People have done much better jobs abroad using 3D printing, concrete 3D printing. We are just at a beginning stage because this is a big investment that we had to do, which we did not. We are just tying up with few local people so that we can understand at the earlier stage that printing can be done using these kind of methodologies. The end outcome, I mean especially the material where we are trying to play around with, right? There is a bonding agent which is necessary again. The materials that we are trying to play around with have to help us out in terms of giving us the end product, which till now it is little difficult. Okay, then comes a machine called thermoforming. Do you know what a thermoforming is? थोड़ा जोर से बोलोगे तो अच्छा लगेगा. Do you know what a thermoforming is? No. मतलब आधे लोग सोए हुए हैं. Good. So this is a thermoforming machine. There are two machines usually. Thermoforming के दो machines आते हैं, जोड़ी में आते हैं. So one machine is a heater, the other one machine is a compressor. So it's got a bed that the girder thing lifts up. Then you have to put a mold inside. Then the whole thing comes down and it sucks the air out. Okay, to give you an end product. So we have to make a mold first. Let us say we have some circular pieces, there's some faceted pieces, and you want 1,000 pieces, okay, of the same design, same detail. At that given period of time, you have to use this kind of a machine. But the materials are restricted in this case. In this case, you can only use acrylic, the polycarbonate sheet, or any composite material, not marble, but composite waste wooden material. Okay, so you have got plyboards today, flexible plyboards today, which can change the nature. Okay, when you put them, when you use, let us say when you use solid surfaces, when you put them into this machine and give a temperature up to 120 degrees Celsius, they change their nature. Okay, initially they are solid format, then they become flexible. You put a mold inside that machine, take this sheet of material which is deformed now, put it onto that, suck the air out, you will get your form ready, and that you can multiply it. And what we have done is we have done some ceilings for a design. So that's what we have tried to create using this machine. So there are multiple pieces which were detailed out because we were doing a ceiling where every piece was different in layers, but in circles they are same. So we had to create different molds and get this job done. On the right you are seeing that we have done a lampshade using acrylic again. So we have used a CO2 machine to engrave first on the acrylic and then bend it using thermoforming machine. So you are using two different machines to get your job done. That is also important. It's not that एक machine है तो यही काम करेगा, but multiple machines can work out and give you different outcomes. Now that's a robotic arm that we have where we can do sculpting as well. We are still working in this area because robotic arms are a little slow right now. The kind of project that we are trying to do and the delivery time that we usually have at that given period of time using robotic arm and getting our jobs done is little difficult at this stage, but we are using them. Now robotic arm is also doing 3D printing. So 3D printing of what? 3D printing of ABS, PET, PLA. So earlier we were having these small machines, but now we are also having these kind of machines where robotic arm is printing up to 2 meters height. Earlier only 450 by 450 by 450, sorry 400 by 400 by 400. But now this can print up to 2 meters height with a radius of 10 feet. Okay, so it can print. And it can print up to a thickness of 12 mm. That's also important. So your time span increases. So you can reduce the time. The time span increases, you can reduce the time and your production can increase. So using these machines, you can get that thing done. So we printed a column recently for one of the exhibitions, in-house exhibitions that we have. Okay, so these are different kind of outputs. So these are multiple machines we have talked about right now. So what are those machines? On the right you can see, you have got power tools. We know what power tools are, right? You know what power tools are? वो भी नहीं मालूम है, हाँ या ना? अरे हाँ या ना? बिल्कुल नहीं. Power tools are what? They are cutting machines, grinding machines, drilling machines. All these are called power tools. Okay, small machine जहाँ पे भी carpenter लेके बैठा रहेगा power tools ही है. Cutter लेके काटता है, that is called a power tool. Okay, all these are power tools. Your architects, come on, you have joined architecture. थोड़ा सा जोश लाओ यार. नींद में है क्या? बोर कर रहा हूँ? No. So those are the machines which are available, that is power tools. Then what I talked about is CNC machines where 3 axis, 4 axis and a rotary is there. 4 axis we have seen this. Rotary is what? You have got X, Y, Z and then there is a column which is rotating. So that's the 4th axis. Okay. Then we have got water jet, metal lasers, non-metal laser, thermoforming, 3D printing and robotics. Other than that we have a manual process. Manual process is necessary at today's stage because all these machines that we are working with, they will not give you an end product. Okay, they will not give you an end product. End product has to be done by human labor. We have to use human resources to get our end product done. Okay. That's the machines that we talked about. On the left, these are the softwares that we are working with. And these softwares are necessary for every designer, every architect, whether you belong to first year, whether you are doing a diploma, you need to learn this at any cost. The more time that you are going to waste, you will be the sufferer. You need to immediately, when you go out, start looking for organizations who teach all this, especially the institutes, who teach all these kind of softwares. So the top up to here, Rhino comes with Grasshopper as a plugin. Then you have got Blender, you have got 3D Max, then there is Houdini, and multiple softwares, Fusion 360, right? AutoCAD is something which we don't use too much for, especially when you are using tools and all. We don't use AutoCAD too much. Then you have these things called NestFab and Cura and Desproto, ArtCam, Mastercam, RoboCam. These are software, these are CAD/CAM tools. These are softwares which convert your three-dimensional drawings that you do in the upper three softwares, they convert them into a programming language. Okay, all these 5, 6 softwares that I've talked about, they convert your three-dimensional design into a programming language. When I'm saying programming language, that means if there is a three-dimensional design, those three-dimensional design have got some points on it, right? Those points, that is X, Y, and Z. So it is a notepad format detail that these softwares convert your three-dimensional surfaces and they convert it into a notepad so that the machines understand this language. Because end of the day, machines को मुझे क्या बताना है? X में कितना distance जाना है, Y में कितना जाना है, Z में कितना जाना है. And if I am rotating, A axis में कितना जाना है, B में कितना जाना है, C में कितना जाना है, the 6th axis. So it converts into a notepad language. So it is a simple word document that these softwares convert your design into. So the machine understands. You should be aware of this. तुम्हें ये जानना बहुत ज़रूरी है. We think that this is not our job, but you should learn them. If you learn them, you can also execute your own design by just writing these notes. You don't need a three-dimensional drawing also. If you can just write the note saying that X point A, Y point A, Z point A, you can do your drawing. I mean, you can build your or probably construct your design. Okay, so these are the basic softwares that we work with. So coming to architecture, what is the kind of an architectural practice that we do? Okay, so we practice architecture interiors using what? Softwares, that is computational programming. Then we use AI nowadays. With AI, we also use HI, that is human intelligence, which is necessary again. Along with that, we use machines